Let us understand chi-square test. All right, let us understand this case study here. Barman Tech Research Company uses 4 regional centers in South Asia: India, China, Sri Lanka, and Bangladesh. And all of these 4 regional centers input the data of questionnaire responses. So they manually perform or conduct some kind of questionnaire surveys, and that response is entered into the computer manually. So they audit a certain proportion of questionnaire responses versus data entry. Any error in data entry renders it defective, and the chief data scientist wants to check whether the defective percentage varies by country or not. And now we have to analyze the data at 5% significance level and help the manager draw inferences. 5%. Significance level is once again alpha. This is type 1 error. 5% is equivalent to 0.05. And in the data set, if you have a 1, it is not defective. And if you have 0, it means it is defective. And here is null and alternate hypothesis. Null hypothesis says proportion of defectives. So let me write it down. Let me write it here. Proportion, and proportion when it comes to your population proportion notation is pi. So proportion of defectives in Indian regional center is equal to proportion of defectives in Chinese regional center is equal to proportion of defectives in Sri Lankan regional center is equal to proportion of defectives in Bangladesh regional center, right? You can write it in that way, or you can say that proportion of defectives across the 4 regional centers is the same. And what does your alternate hypothesis say? Proportion of defectives in proportion of defectives in at least 1 center is different. In at least 1 regional center is different. We cannot say that proportion of defectives are not same. We cannot say in that way because look at this. Either I can write it in this way that proportion of defectives in India is not equal to China, is not equal to Sri Lanka, is not equal to Bangladesh, or there could also be various scenarios such as proportion of defectives in Indian region is equal to China, which is not equal to probably Sri Lanka, and which is not equal to Bangladesh. Maybe this is one scenario. Another scenario could be this is not equal to this, but this is equal to the proportion of defectives in Sri Lanka. So there are a lot of possibilities available. So you can never write it that proportion of defectives are different. Yeah, we cannot write it in that way. Hence, proportion of defectives in at least 1 center is different. That is how we write. Now let me open this data set in Minitab and let us try to solve that. Here we go. Here is the underlying data set. So we have the proportion of defectives, or we have the defective count for India, China, Sri Lanka, and Bangladesh. If you have 0, there is no, it's not defective, and if you have 1, it is defective. All right. So now we can stack this data and place this data into 2 columns. For Minitab to understand, this is what we are doing. We're going to stack this data. So let me delete these two and show it to you up front once again. Okay. In order to stack the data, you need to go to data, stack the columns. You have chosen India until Bangladesh here, all these four, and you're storing the output in the same worksheet, in the current worksheet. And you're saying that you want column names in C7. You want column names in C7. So what are your column names here? India, China, Sri Lanka, and Bangladesh, right? These are your column names. These column names, I'm going to place it in C7. And then we are going to store the subscripts. My bad, here, just a small change. In C7, you will have all these row values, right? And store subscripts in C8. So these column names would come here. Let me do that here. So 0, 0, 0, 0, all these values are stored here. And then wherever you have India, these are all the values pertaining to India. So against that, we have placed India. And then if I scroll down, you have China, right? From here, all the values down are pertaining to China, and then you have Sri Lanka, and then you have Bangladesh. All right. Now let us perform the chi-square test. You need to go to Stat, Tables, chi-square test for association. You need to do that. And you have this, let me delete that. Your C7 contains all the row entries, right? Here, what is a row? All these are rows, whether it is a defective product or not, right? And all those row entries are there in this column called C7, so let me select that. And all these column names, India, China, Sri Lanka, and Bangladesh, the column names are there in this C8. And let me click on OK. There we go. We have a p-value here, which is 0.626. You can either choose Pearson chi-square or likelihood ratio chi-square value. It is 0.626. Right, so let me go here. So p-value is 0.626. And what does this imply? This implies that p-high null fly, which implies you accept null hypothesis or fail to reject null hypothesis. That means you go back to your chief data scientist and say that the proportion of defectives across all these four regions is the same. So we need not take any action.